In this question, if the electric lines of force are as shown in the figure, so electric intensity at A and B are E and A respectively then. Okay, so question asking you to compare the strength of electric field. So you can compare it over here. So if you see, I already said that if the lines are closer means, if lines are closer means electric field strength are high. If lines are closer means electric field strength are high. So we'll go with option A. We'll go with option A. So now we are moving for next question. Next question is two concentric hollow conducting sphere of area R1, R2 and charge Q1 respectively. If R1 is greater than R2, then the electric intensity at a distance R from the common center. The question is asking us, okay, this is pi, this is basically pi, in place of box, this is pi. The question is asking separated and. Okay, R1 is greater than R2. Electric field intensity at a distance R from the common center. So electric field intensity at a distance R from the common center is what? So here R is between R1 and R2 and Q1 and Q2. Okay, see charges Q1 Q2 respective to concentric hollow conducting sphere. So think, can we get the null point in between? Can we get null point in between Q1 Q2? In between Q1 and Q2? Can we get null point? So if the field due to Q1 is 0 because the point P is inside the outer cell, so it is outer the inner cell, okay? So what will be the electric field? Electric field will be what? Q2 by 4 pi epsilon naught R2. So we'll go with option number, okay, 2. We'll go with option number 2. So next, and next. Okay. Next, we are going with next question. So a solid metallic sphere A is placed concentrically inside a hollow spherical conductor B as shown in figure. The positive charge Q is given to A and B, and R. The electric intensity inside A is 0. On the surface B is 0. Between A and B is not 0. All the above are true. You can see the picture. Solid metal sphere A is placed concentrically inside a hollow spherical conductor B. So take care of the thing that this is solid metallic sphere A, and placed concentrically inside a hollow spherical conductor B. Okay, so this is solid, and B is hollow, and we earth the B as B is connected with earthing. Okay. So now question is asking the electric intensity inside A is 0, on the surface of B is 0, and between A and B is not 0, and all the above are true. So, what is the answer for these questions? If you see, as metallic sphere, being metallic sphere, the field is 0 inside the sphere. Okay, so B is earth and hence charge on surface B is 0. So between A and B, the field is due to A. Okay, so there will be field between A and B. There will be field between A and B. There will be field between A and B. The outer surface already earthing connected with earth, so charge 0, inside is 0, so between A and B. Next question we are going with, a non-conducting solid sphere of radius r and uniform charge, the magnitude of the electric field due to the sphere at a distance r from its center. A non-conducting solid sphere of radius r uniformly charged, the magnitude of the electric field due to a sphere at a distance r from its center increases, okay, increases as r increases from R is less than R, non-conducting solid sphere. This is what non-conducting solid sphere. You know, electric field due to non-conducting sphere is what? Okay, K Q by R cube into R. Okay, why I'm saying this? Because this is non-conducting. This is non-conducting. So inside increases as increases. Okay, R increases because R is less than R means we are talking about inside the sphere. We are talking about inside the sphere. The sphere at a distance R from its center is. So what is the correct answer for these questions? Okay. So inside this relation valid R. So I will go with option number first. Okay, very linearly. Okay. Inside the sphere varies linearly. So we'll go with option number first. Next question. Next question. This is wrong actually. This is R cube. Okay. So this is okay R cube. Okay. R cube into R. This is R cube into R. So next question we are moving for next question. Next question is two positive charge Q and Q are placed at the diagonally opposite corner of the square, and two negative charge these are placed at the other two corner of the square. Then at the center of the square, the resultant electric field intensity E and the net electric potentials are. The question is asking net electric potential, net electric potential. So basically what two positive charge will be placed diagonally opposite corner of a square and two negative charge minus q are placed at the opposite two corners of the square. Okay. So electric field not zero. These options are in front of you. So come to the solution part. So what is okay? If you see the figure plus q. So because of this, there will be electric field. Net electric field will be what? Net electric field will be what? Zero. Because of plus q. So this then at the center of the square of resultant electric intensity. The question is asking us at the centers. If you at the center electric field because of this charge will be okay in this direction, and because of this charge will be in this direction, and net electric field magnitude will be same, so electric field will be zero. On the same way, vice versa, electric field because of this charge and this charge will be zero. This charge and this charge will be zero. Okay, and potential, as you know, potential here, so potential scalar quantities, if you add over here, okay, all potential, if you add all potential because of plus minus all are same place, situated at same place, so potential will be also zero. So we'll go with the option number third. Next question we have. So next question we have is a proton and electron are placed in an electric field. Both move in same direction, and in the direction of electric field, they are not accelerated. Electron moves from lower potential to higher potential. Both moves in mutually opposite direction. Proton and electron are placed in electric fields. We are placing proton and electron. We are placing proton and electron in an electric field. Okay. So obviously both will move in opposite direction. Yes or no? So proton and electrons are positively charged, so they move in opposite to a direction, that is field very lower to higher potential. So we'll go with option number 4. Next question: identify the correct order of following particles when arranged in the decreasing order of kinetic energy when moved from same time in the same electric field. Correct order of the following particles when arranged in the decreasing order of kinetic energy when moved from same time in the same electric field. So electron, proton, neutron, tritium. So this option is given. So question is asking us the particles arranged in the decreasing order of kinetic energy. So arranged in decreasing order of kinetic energy. So when moved from same time in the same electric field. Electric field is we are giving the same electric field. So in the same electric field, okay, you have to arrange the kinetic energy basically. So kinetic energy what half mv square, and velocity is what a into p square. And I already said acceleration depends on q by m. Acceleration depends on q by m. Acceleration depends on q by m. So basically here acceleration okay depends on q by m. So charge of all the particle is same. So kinetic energy is inversely proportional to m. So accordingly you can arrange it. You can arrange it because the mass of tritium is more than neutron respectively, then less proton and then less electron. You need to take care of basics concepts. Definitely you can do correctly these questions that mass of electron is less, and then completely proton is higher, than completely neutron is higher, and tritium is higher. So this is conceptual question. So if you understand, definitely it will benefit you. Next question of Q upside B has a charge Q at each of the vertices. The electric field due to this charge distribution at the center of the cube is given by. So the electric field E due to the charge distribution at the center of cube is given by cube of side B has a charge Q at each of its vertices. Okay. So each vertices have a charge Q, has a charge Q. So this is very fantastic question because of symmetry. The net electric field at the center of the cube is zero. We will go with option number C. Option number C. We are moving for next question. A proton and an electron are projected parallel to an electric field, then both experiences same acceleration. I already said acceleration depends on q by m, and already I showed you the kinetic energy, variation of kinetic energy. So accordingly, if you do, so you will get the correct both experiences same force. Proton and electron projected parallel to electric field experiences the same force. Both gain same kinetic energy while travel through the same distance. Okay. So proton and electron here. So both gain same kinetic while travel in both the same distance. So see, what I'm saying here. So kinetic energy, what the charge of proton electron is same, but the mass of proton is more. That is 1840 times. So that of electron. So force experience will be same. Okay, because why the force experience will be same? Because charge is same. Because charge is same. Okay, so because charge is same, so force experience will be same and distance travel is. So what I'm talking about half mv square. What I'm talking about half mv square. So if you work on velocity, so what finally we are observing that okay, S is the same kinetic energy, same for both electron and proton. So you can go through it, you will understand definitely it. We are moving for next question. So statement one electron of mass m charges E is placed in electric field strength E, it is accelerated in any direction. An electron of mass m charge E is placed in an electric field strength E, it is accelerated in any direction. Okay. So if you keep a electron of mass m charge E is placed in an electric field strength, it is any direction. Acceleration of electron is in direction opposite to electric field. This is easy question. You can go with this. This is easy question. You should do. The electron accelerating in the direction opposite to the direction of electric field. So we'll go with option number 4. Next question: when a proton and alpha particle are projected with the same kinetic energy against the electric field of same distance, then the distance traveled by the proton is more than that of alpha particle. So what you have to observe here, the mass, if you see the mass of proton alpha particle thing, which will come to rest, and the electric force experienced by the charge particle is directly proportional to magnitude of charge in a given body. Question: electric force experienced by the charge particle depends on directly proportional to magnitude of charge and so options we have to see. If we see initial kinetic energy is same, so the final kinetic energy depends on work done on the particle. So electric field is conservative. So from work energy theorem, final kinetic minus initial kinetic energy change in work done. So final kinetic energy work plus kinetic energy. So work we are doing. So we'll go with answer P1. Next question: when a positively charged particle is placed at the point of suspension of simple pendulum whose bob is charged negatively, then tension in the string is less than initial value. Positively charged particle placed at the point of suspension of a simple pendulum whose bob is charged negatively. So see, basically what bob is charged negatively, and question is talking about positively charged placed at the point of suspension. So then the tension in the string. Question talking about tension. Negatively charged particle experiences the force opposite to the electron direction of the electric field due to positive charge due to positively charge. Okay, so you need to go with the options and try to find out the correct answers. So see, due to negative charge at point of suspension, it attracts positively charged, hence tension decreases. It's a simple logic. If you apply, you will get the answer. Next, when a small positively charged sphere is projected up vertically, where the electric field is vertically downwards, then maximum height reach is less than when electric field is absent. Okay. So a small positively charged sphere is projected up vertically, where the electric field is vertically downward. Electric field is vertically downward. Take care, vertically downward. Electric field is vertically downward, and we are putting positively charged. Then the maximum height reach is less than when electric field is absent. Less than maximum height is less than okay when electric field is absent and positive charge particle experiences force in the direction of electric field. Again, this question is very easy questions. If you do this question smartly, definitely you can okay crack this question. So what is the answer for these options are given in front of you. So answer will come. Okay, so see, electric field is in downward direction. So because of positively charged particles, so force will be in downward direction. Yes or no? So acceleration is also in downward direction. Next question. So electric and gravitational fields are acting along same line. When proton alpha particle projected up vertically along that line, the time of flight is less for proton. Electric and gravitational fields are acting along the same line. Okay, when proton alpha particle projected up vertically along the line, the time of flight is less for proton. See, question is asking saying that time of flight is less for proton. Basically, you need to focus on gravitational. So question talking about electric and gravitational field both. Okay. And in the given electric field, acceleration of a charge particle is directly proportional to a specific gravity. So if you're talking about electric field, the question is saying the acceleration particle is a specific gravity. A specific of a charge means what? Suppose a specific term is Q by M. The mass of protein less than alpha particle, so G is independent of mass. So the time of flight for proton is less for proton, and G is more for proton. Okay, yes or no? So the time of flight for proton is less for proton, and G is this mass of proton is less than alpha particle. Okay, so G is independent of mass. Small G is independent of mass. Okay, basically what you observe QE plus ka G by M. Okay, QE plus ka G by M. So use your sense here. Definitely you'll get your answer. Next, we are moving for next questions. Two particles of same charge projected with different velocities. Normal to electric field experiences same force, but when projected normal to magnetic field experiences different force. Okay, two charges of same charge, two particles of same charges. Okay, so electric field, basically talking about electric and magnetic field, a charge particle experiences velocity independent, a charge particle experiences velocity independent force in electric field and velocity dependent force in magnetic field. Charge particle experiences velocity independent force in electric field and velocity dependent force in magnetic field. Okay. So question is saying the charge particles experience force velocity dependent in magnetic field and velocity independent in electric field. Okay. So again, this is good question. This is good question. So you can correct this question. So basically, what you can go with options. Basically, what we are talking, electric force is F equals to QE and magnetic force is QV cross B. We can go with option number one. Okay. Next, two sphere of radii R1 and R2 are charged to same surface density. Then they have electric field of same strength on their surfaces. So electric field of same strength on their surface. Two spheres of radius R1 are to charged to same surface density. Same surface density. Then they have electric field of same strength on their surface. Okay. Surface density is charge per inch area. So what is correct answer? What do you think? Your answer is match your answer. So basically same surface charge density means what? Q1 by 4 pi R1, Q2 by 4 pi R2, and here electric field is what? EQ by 4 pi epsilon of R squared. So we'll go with option number one. Next, we are going for next question. The figure shows the plot of lines of force due to two charge Q1 Q2. Estimate the sign of charges. So Q1 and Q2. So basically, see Q1, okay, terminating electric field on Q1 as well as on Q2, also terminating electric field on Q2. And see, there is repulsion means so both are of same nature. So what is your answer? Negatively charged and both are negative because terminating because force are repulsive. Those electric lines are repulsive there. So both are negative. So now we are moving for next question. In this question, see uncharged sphere of metal placed inside a charged parallel plate capacitor. The electric lines of forces look like an uncharged sphere of metal, placed inside a charged parallel plate capacitor. Okay, uncharged sphere of see what we are doing. Uncharged sphere of metal placed inside the charged parallel plate capacitor. So charged parallel plate capacitor, we are kept uncharged. Okay, uncharged metal placed. The electric field lines of force looks like. Question is talking about electric field lines looks like. So what is the answer? So what is your answer? Okay, so looks like this. So if you see the answer, field lines are always perpendicular to conducting sphere similar to this. So answer will go with answer key. We will go with answer key third. Okay, next question. Figure shows lines of force for a system of 2-point charges. The possible choices for the charges is this. This is the figure. So this is the figure. This is the figure. So the lines of force for a system of 2-point charges. Lines of force for a system of 2-point charges. Okay, this and this. The possibilities are this. So because F is number of lines, Q1 is positive. Obviously, Q1 is positive. Q1 is positive because electric lines are going out from this, and Q2 is negative, so it's coming in there. Okay, and if you see the number of lines, so here is 8, and there is okay 2 to 4. So it is 2. So we can go with like this. Okay. So next question in front of us, the figure shows the electric lines of force emerging from a charged body if the electric field at A and B R and respectively if the distance A and B is R. Okay, distance at A and B is R then. So question talking about electric field at A is greater, electric field at B is greater. Okay, this is easy questions. Just use your science. Just use your simple sense. Everyone will get your answer. So closer the field lines, stronger the field. So EA is greater than B. EBA is greater than AB. If you observe this, we'll go with option number first. No, okay, conclusion. Next question we have two identical positively charges are placed at the corner A and B and associated triangles. The direction of field as of other vertices C is, okay, so identical positively charge are placed. So basically we have placed a corner of isosceles triangle. The question is talking about positively, it's a positively charged, it's a positively charged, okay. The direction of field lines, other vertices C is parallel to AB, parallel to B. So this question is talking about this. Okay, so basically we place positively charged. Okay, we place positively charged. You see, we place positively charged. So electric field because of A is like this. Electric field because of A is like this. Electric field because of A is like this. So resultant will be like this, which is perpendicular. Which is perpendicular bisector of AB and always away from C. Away from C. So hope all of you understood all the concepts. This concept is very useful for your preparation point of view. Thank you.